हेलो। हम्म। ठीक है ना? ओके, सो नमस्कार. This is our second class of Introduction to Robotics. So in first class we started from here, and we learned the definition of robotics. Then we learned the definition for robot, and then we started from the history. Okay, so basically we are more interested in modern robotics. Okay, so before uh, this modern robot that is developed by George Devil, there were several robots were also there. So before Unimate robot, there were also robots, but this is the first. Unimate is the first programmable robot, programmable robot. Okay, that is why we are more interested in this. Okay, so that is why we are we are not exploring the history before. Okay, so Unimate was the first robot, and Unimation was the first company which developed this robot, and the first robot Unimate has been installed in the General Motor Factory in 1961. Okay, so in this way, the first generation robot, modern robot, the journey of first generation modern robot had been started. Okay, and then we've seen various other robots like Puma, then Kuka. Okay, so in this way, Skara, then second generation robot, that is robot 1, then robot 2, and then fourth generation robot, that is Evo. Okay, so uh, how we have introduced AI in robotics, and then today's generation, advanced robotics, AI based advanced robots. Okay, so in this way, then we also have seen various types of robots. So like uh, manipulators, industrial robot, then wheel robot, then legged robot, then aerial robot, underwater robot. So we have just seen this. Okay. Later on in upcoming classes, we will learn in detail. Okay, and we will also learn the kinematics of this type of robots, kinematics, dynamics, and various design aspects. Okay, of robot. Then bio-inspired robot we have learned about. Then micro robot. Okay, so in this way we have basically uh, uh, learned about robot, and we have seen various types of robot. Okay, now uh, two term. Okay, so initially we have discussed about the robotics. Okay, so robotics is what? Robotics is a multidisciplinary branch. Okay, robotics is a multidisciplinary branch which involve mechanical, electrical, computing. Okay, and if you have heard about mechatronics, mechatronics is also a engineering discipline, okay, a multidisciplinary course in which students learn about electrical, electronics, computing. Okay, so it seems uh, means mechatronics and robotics both are similar. Okay. Hmm. But mechatronics is a wide course, wide field. Okay, robotics also come under mechatronics. Okay, so all the system, all the robotic system can be can be called a mechatronic system. Okay, but all the mechatronic system can't be called a robotic system. Okay, like this mouse. Okay, this mouse has design. Okay, structural design that is come under mechatronics. We have a like this roller. Okay, that come under mechanical device, mechanical engineering, and then there is a battery that come under electrical, and then there is some IC, okay, that come under electronics, and that IC has been programmed, so that is come under computing. But this is not a robot. you can say this is a mechatronic system. Okay. So similarly, this watch. Okay, if you will see this watch, so this design of this watch come under mechanical system or mechanical engineering. Okay, battery and circuit come under electrical engineering, and then small ICs, transistors come under electronics, and that ICs have been programmed that come under computer science engineering. Okay, but this is not a robot. You can say this is a mechatronic system. Okay, so then what is robot? Okay, how we will distinguish between a robot and mechatronic system? Okay, so for that we follow the Asimov's law. Okay, Asimov's law, three laws given by Asimov. Actually, Asimov was not a engineer or a researcher. He was a science fiction story writer. Okay, and he has given these three laws for robotics. Okay, in 1941. Okay, but before that, in before 1941, this word robotics or robot was already being used in various stories or articles. Okay, uh, we seen initially that Karel Čapek has first used this word robota in his article in his story. Okay, so this this was this term robot was already being used in various story and article, but in negative sense. People were writing various science and fiction stories, and they show the wrong figure of a robot. Okay, they show the how robot will destroy the humanity, how robot will be harmful for the humanity, for the human being, how that robot, that machine will fight with this civilization. Okay, so this is how the many people written or various stories, but they shown or uh, they shown the bad face of the robot. Okay, that is why Asimov bring these laws. Okay, three laws. Okay, and tell us that if robot will follow these three laws, then only we will say this is a robot. Otherwise, we will not say this is a robot. Okay. So what are that law? The first law is what? The robot may not injure a human being or through inaction allow a human being to come to harm. Okay. First law is what? Robot will never harm a human being. Oh, okay, or never allow human being to be harmed. Okay, means what? The first, if you have a mechatronic system, but that mechatronic system is harming someone, some human being, that mechatronic system can be called a mechatronic system, but that system never will be called a robotic system or robot. Okay, why? Because that system, mechatronic system, has violated the first law of robotics, and that has harmed a human being. Okay, uh, that is why the robot must should follow the first law. Okay, then second law is what? A robot must obey the order given to it by human being. Okay, so if you have developed a robot, but that robot is not obeying the instruction given by human being, then that robot will not consider as robot. Okay, except where such order would conflict with the first law. Okay, but yes, if someone is giving order, okay, giving order to the robot and saying that please kill that human being, then again the first law is being violated. Okay, so if first law is being violated, then that robot will not obey the order of human being. Okay, that robot must should obey the human being, but first law, okay, should not be violated. Okay, if someone is giving order to a robot to kill human or to kill the human society, then it is uh, conflicting or it is violating the first law. At that moment, at that time, robot will not obey the second law. Okay. Then third law is what? A robot must protect its own existence. Okay. So a robot must protect its own existence. Okay. So robot also have uh, right to protect itself, right to survive. Okay, but it should not violate the first and second law. Okay, if a robot is harming human being and if a robot is not obeying the human being, then that robot is not a robot and that should not exist. That robot should not survive. That machine or mechatronic system should not survive. That is not a robot. Okay. That is why most of the defense system, which are basically for killing human, okay, can we can say enemies, but that enemies are also a human being. So that is why most of the defense system are not come under robotic system. Okay. Then, so this law is given first, these three laws are given, but later on, this Asimos have revised this robot, this laws, and added one more laws. Okay, that is called zeroth law of robotics. Okay, so this is what robot may not harm humanity. Okay, so now first law is what? Law of robotics was that robot will not harm a human, but the zeroth law is what? Robot will not harm the humanity. Okay, means what? Humanity and what is the difference between human and humanity? Human is a one person. Human means a indicating one person, but humanity is a collective word. Okay, for society, for human race, for human civilization. Okay, like that. That come under that is means humanity means a collection of human like that. Okay, so for example, suppose imagine a person is about to release a dangerous virus that could kill millions of people. Okay, so what robots should do? According to first law, robots should not harm an individual human being, but according to second law, robots should must protect humanity. Okay, now here the robot will follow the zeroth law. Okay, it will kill the okay kill or protect the humanity, kill the that person who is causing or stop that person who is causing to harm the humanity. Okay, so okay, so in that case, so that is why this zeroth law has been introduced. Okay, okay. So now we will move to the next, that is the basic component of robotics. Okay, basic component of robotics. So if you will observe any robot, if you will observe, okay, let me show you some video like this. Okay, these are humanoid robots. Okay, so if you will observe these robots, so if you will see, basically they are basically uh, four components. Okay, there will be a controller at the center. Okay, there will be actuators in form of motors. Okay, at the joints, and there will be sensor like camera or touch sensor or ultrasonic sensor, lidar sensor. Okay, and fourth one is the power system. There will be some battery which will power all this actuator, controller, and sensor. Okay, and one more thing will be there, but that will be away from this robot. That is a interface, control interface. Okay, but that may not be the part of this robot. Okay, that will be a separate system through which we can control the robot. Okay, so this diagram, what this diagram is showing, this is the controller, that is at the center. Okay, now this is the actuator. Okay, so from controller, actuator is getting instruction, that is what this arrow is indicating, and this actuator is getting power from this power conversion unit or battery. Okay, and the sensor is sensing the signal, and that signal is again sent to the controller. That is why this arrow is in this way, and the sensor is also getting power from the power system, that is battery. Okay, and there will be a remote control or user interface. Okay, that will directly or indirectly connect with the controller. Okay, and that may have a separate power system. Okay, so in this way, basically, if you will observe all the robots, okay, these four components, oh, okay, 4 or 5 components will be there. Okay, like I have a simple wheel robot. Okay, so this is the controller. Okay, and this is the actuator. Okay, this is the actuator. Motor, that is gear DC motor. Okay, and uh, in this robot, sensor is not used. Okay, so in this robot, sensor is not used, and this is the power system. Okay, so through this, actuator is getting power, this controller is also getting power, and this is for connect with the user interface. Okay, so I control this robot through my mobile application, and through this Bluetooth module I communicate with this robot. Okay, so there is no sensor in this robot. Okay, so uh, let me show another robot. Now I have another robot. Okay, so in this you can see this is the controller, and this is power system, and this is motor. This is the motor, that is actuator, and a light sensor LDR is being installed. Okay, this is LDR sensor. Okay, now all the components which I shown in the image are available here also. Okay, so in this way, if you observe all the robots around the world, okay, these 4 or 5 components will be there. Okay, basically. Okay, maybe less than this, like in other robot I shown, there was no sensor. Okay, so in that case, component 3 or 4 components were there. Okay, but maximum these 4 components will be there. Okay. Okay, so now we will discuss about how to select a robot. Okay, because if we want to, suppose I have this small mouse, okay, small mouse. Suppose I want to pick this and place somewhere using a robot. So we will not bring a big robot to hold it. Okay, and at the same time we will not bring a small robot to hold it. Okay, so based on the challenges, based on the problem, based on the action to be activity need to be done, we select the robot. Okay, and based on that we have given some name also, like small robot. Okay, robot having dimension less than 10 centimeters. Okay, are come under small robot. Okay, then mini robot. So small robot, the range of small robot will be more than, greater than, the size will be greater than 10 centimeters and less than 100 centimeters. That type of robot are come under small robot. Then mini robot. Mini robot, the size of mini robot will be greater than 1 centimeter and less than 10 centimeters. Okay, and then milli robot, the size of milli robot will be greater than 1 millimeter and up to 1 centimeter. Okay. Then micro robot, the size of micro robot will be less than 1 millimeter up to and greater than 1 micrometer. Okay. And the size of nano robot will be uh, less than 1 micrometer and greater than 1 nanometer. Okay. So in this way, based on the size, we uh, give the name also. Okay. And according to the task to be done, okay, we choose various type of robot. Now I think you are clear with the name. Okay, because by observing a robot, you will predict what will be the maximum size of this robot, and accordingly you can also give name. Okay. Then again, medium-sized robot, the robot having size greater than 1 meter and up to 5 meters are called medium-sized robot. Okay, and large-sized robot are all the robots greater than 5 meters are come under large size robot. Okay, and then based on the degree of freedom, we choose robot. Okay, suppose we want to pick and place. So uh, 1 degree of freedom or 2 degree of freedom is maximum will require. 1 degree freedom or 2 degree freedom will require to pick and place a material. Okay. So in that case, we will not choose a robot having three degree of freedom or 5 degree of freedom, because when degree of freedom increase, number of actuator increase. The controlling robot become more complex. Programming become more complex. Power power uh, power required increases. Okay, that is why based on the activity, okay, based on the performance work, okay, which need to be performed, we choose the degree of freedom. Okay, so based on the so in this way we select the robot. Okay, then velocity is also a thing. Based on that we choose the robot. Okay, so suppose you want to do a task very fast, so in that case you will not going to choose a robot having size very slow, which perform very slowly. Okay, so we need a high velocity robot. Okay, so velocity is also a concern, or a term. Based on that we choose a robot. Then drive type. So drive type means what? Sometimes we have electricity available. So when electricity is available around us, in that case, motor will work. Okay. Or sometime when electricity will be available. So in that case, hydraulic actuator will be used. Sometime when we need to carry a very heavy load, and in that case also hydraulic type of drives are used. Okay, and sometimes we need precise motion. In that case, electrical drives are used. Okay, so based on that, we choose various types of drive. Okay, and then control mode. We will learn in upcoming classes various control modes. Repeatability. Okay, repeatability means what? Suppose you want to uh, perform a task. Okay, you want to repeat a task for 10 times. Okay, okay, and maybe you want a robot which will perform for years and years. Okay, so number of cycles will be thousand cycles, more than lakhs cycle will require in that case. So based on the repeatability required, we choose robot. Okay, so if we will choose a simple robot and we will not consider this repeatability, then what will happen? After performing certain cycle, it will start giving and performing uh, start performing poorly. Okay, it will start making error. It will start making a less precise action. Okay, then lift capacity. Okay, so suppose you want to lift this small mouse, so in that case, accordingly you are to design the manipulator. Okay, and if you want to lift this small connector, so in that case, uh, accordingly you are to develop, choose the motors and link and size of robot. Okay, so lift capacity, then weight of robot. Okay, so where that robot need to be, weight of the robot is very important factor. Suppose you want to send a robot to the space or moon. Okay, so through satellite you are going to send that robot. So the robot weight is very big factor. Okay, while designing a robot for moon or um, for sending that robot to the Mars or the other planet. Okay, so because if weight will be higher, more fuel will require, more thrust will require, more system, and the operation will become more complex. Okay, so in this way we select robot. Okay, now what is the application of manipulators? So industrial robot are, means wide application are there. Okay, and these are the country where this industrial robot are being used. Okay, and you can see Japan. In Japan, this industrial robot is widely used. Okay, Singapore, then South Korea, then Germany, then Sweden, then Italy, Finland, Belgium. In this way, these are the country where robots are widely used for performing various tasks. So which tasks it can perform? Like material handling, pick and place, then various type of processing operations like welding, cutting, spraying, painting, packaging, okay, grinding, cutting, etc. Sometimes it is used for assembly also and for inspection also. Okay, so these are the application of industrial robot. Okay, so for various robots, there will be a number of applications. Okay, and now I have discussed many robots. Now your task is to explore all these robots like wheel robot, legged robot, and then underwater robot, soft robot. I have discussed with all robots. Okay. Now you simply go to the ChatGPT and simply ask what is the application of legged robot, then what is the application of air robot, what is the application of underwater robot. Okay. What is the application of this hybrid robot? Okay, humanoid robot, application of humanoid robot. Okay, now your task is to explore through internet. Okay, so now I will, uh, this is the last slide. So what is the advantage and disadvantage of robots? So advantage is what? Uh, when we use a robot, so productivity, safety, efficiency, quality, and consistency of the product will uh, become higher. Okay, so suppose a human being is making a part uh, in 1 hour. So within that 1 hour, a machine will make a thousands of parts. Okay, a robot can make thousands of parts. And sometimes it happened while doing a welding or cutting or doing various operations. Okay, so people get hurted. Okay, while doing these operations. So in that case, robot do it safely. Okay, and as human is more directly in contact with the various operations, if something wrong will happen, that robot will face that. Okay, and the life of human will be safe. Okay. Similarly, efficiency will be higher. Okay, so efficiency of the whole system increase when we use a robot. Okay, so what means efficiency is what? Efficiency ratio of output to the input. Okay, means you are giving uh, some raw material to a company and power and various in form of electricity, in form of human resources you are giving to that company, and we are getting output in form of product, okay, from that company. Okay, so so when we use a robot, in that case initial cost may be higher, but with time the number of product, the benefit, the profit of that company become too much high. Okay, and in this way, the output ratio of output to the input become higher. Okay, and hence the efficiency increase. Okay, quality quality of a product. Suppose see this mobile. Okay, so if a human being will make it, it will become like an impossible task, very difficult task. Okay, when a human being will make this system manually. Okay, but robot do it with quality and consistency. Okay, means thousands of similar type of mobile phone will be created. Okay, and there will be no difference if you will look it as, from its outer appearance. There will be no difference. Okay, so with consistency, the robot produce a high quality product. Okay, and then sometime when we want to operate like in tunnel or in boiler, uh, or somewhere dangerous place. Okay, so in that case, this robot can easily operate. Okay, in that case. Okay, so without life support, comfort, or concern of safety, life safety, robot do it nicely. Okay, so if you will send a human being to make a tunnel, okay, under the big hill or under the land, okay, so in that case we need to provide life uh, support like oxygen and that environment. Okay, but when we start using robot, no required. Okay, this support no required, no longer required. Okay, so in this way there are many uh, advantages, like robot work continuously without experiencing fatigue or boredom. Okay, so human get bored. Okay, after doing after doing a task for hours and hours, get bored. Okay, and they get tired. Okay, but robot never bored, never tired. Okay, and it can perform years and years. Okay, same task. Hmm? There is no insurance, there is no vacation, there is no hangover. Okay, robot has the repeatable precision at all time. Okay, so as human is a emotional being. Okay, so suppose I am making this, okay, this pen, and suddenly I will get I will remember my father. Okay, so in that case, I will get emotionally, I will get emotionally broken, and maybe I will perform wrongly. Okay, so in this way, there are many advantages. Okay, at the same time, many disadvantages. You may say disadvantages, but overall advantages more, and disadvantages maybe there will be there when a new system come uh, in our society. At that time, the social trend or social activities which are working for years get replaced, and at that time people belongs to that activities or belongs to that business get hurted, but with time people adopt the new things also. Okay, so this is all happening for years. Okay, okay, so now we will stop here. In next class we'll learn the various terminologies related to robot. Thank you.